Welcome back, everyone. So, my name's Emma, and for this week, we are going to be doing some penny chemistry, showing the reverse reaction of penny oxidation. So, the materials that we will need for today's experiment can be commonly found around the home, or if they're not around the home, you can purchase them for a couple of bucks at your local grocery store. Now, first, we always want our PPE. We have our nitrile gloves, our safety goggles, because we only get one set of working eyes, super important. I don't have a lab coat, so instead I'm just wearing some clothing that is covering up my body. Same thing with my long pants. And you always want to wear closed-toe shoes because while we are working with everyday chemicals, we always want to be safe. And safety comes first because you can never be too sure what's going to happen. Plus, I can tell you from personal experience today that without your gloves, the reaction between two of the household chemicals, particularly the acid and the salt, can be a bit corrosive. I just know this from personal experience while trying to clean some dishes. Okay, so for today's experiments, we're going to need a paper towel, whatever paper towels will do, a non-metal spoon or stirrer, a chopstick works fine, plastic spoon works fine, I'm just going to be using this one, a non-metallic bowl of some sort. I have this glass bowl here. It is a Pyrex bowl. You can use a ceramic bowl. That works totally fine as well. Plastic bowl, totally fine. You also want to have some salt. And some water. A separate bowl. As well as an acid of some sort. So today we can be using vinegar or some lemon juice. For today's purposes, I'm going to be using some lemon juice, but I promise you the reaction is exactly the same. And most importantly, we want some pennies going on. So, the dirtier the pennies, the better. You can see here these pennies are pretty dirty. Okay. So, the objective of today's experiment is going to offer a visual demonstration of the reversal of a chemical reaction known as oxidation. So you're probably wondering, why do we need the dull and dark pennies? Why can't we just use, a shiny penny? Why do we need to use this one for today's experiment? Well, it's because pennies are actually topped with copper. We are taught that pennies are actually made of entirely of copper, but this isn't true. They're actually mostly made of zinc with its a coating of copper, particularly pennies in more recent years, about sometime after 1980 more or less. So that's the bulk of our pennies that are in circulation for today. So when we have the oxygen within our air, within our atmosphere that we breathe in, there's actually an interaction with the copper coating. And that interaction results in an appearance that makes the pennies dull and dark. So the oxygen in our air that we breathe interacts with other substances, but most of the time an oxidation reaction occurs with a copper coating. So what exactly is an oxidation reaction? Well, it's when there's a loss of at least one electron when at least two or more substances interact. Substances may or may not include oxygen, but in this case, it is oxygen. So what type of reaction do you think that is, this oxidation reaction? Do you think it's a physical reaction or a chemical reaction? If you're not too sure, you might want to check out our first week's presentation. Chemical reaction, ding, 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 if you guessed it. Okay, so you might be wondering, does this have any real life applicability besides just having dull pennies around? Well, you're in luck because you have definitely seen this before. When we have fruit that's exposed to oxygen, it tends to spoil a little bit faster. I'm sure we've all, had some cut up fruit, left it out in the open, didn't cover it with some saran wrap, it went rotten a lot faster. Also, inside of our bodies, when oxygen reacts with glucose, it produces energy, which we all need. Okay, so you've all probably seen a brand new, shiny looking penny. It doesn't necessarily need to be brand new, but you've probably all seen shiny looking pennies before, right? Okay. And then over time, even if the penny was new, made in the same year, 2020, over time, it just kind of gets dull and dirty, as you can see. So this is because the penny's copper coating interacts with the oxygen in our air, and it winds up forming copper oxides. Now, these copper oxides leave a dull and dark coating on pennies. So if you're wondering, here's the reaction. We have the copper coating on top of our pennies, interacts with the oxygen that's in our air and our atmosphere, and it reacts together to wind up forming copper oxides. All right, so now let's begin the experiment. We are going to take our bowl right here, and we are going to pour 1/4 of an acid, in this case either vinegar or lemon juice. I'll be using lemon juice today, 1/4 of a cup into our bowl. Okay, so just all right, now we are going to add our salt. We are going to be using 1 teaspoon of salt. I had that pre-measured. Okay, now we're going to stir this acid and salt mixture, in this case lemon juice, or you might be using vinegar at home, mixture with our plastic spoon. If you don't have a plastic spoon at home, a wooden chopstick works fine too, a plastic chopstick works fine, totally works fine. Now we're going to stir it completely until the salt is completely dissolved. The lemon juice. We'll know it's completely dissolved when the mixture goes clear if you're using vinegar at home, or until we don't see any residue down at the bottom with the salt. You can also maybe hear it a little bit. You hear there's not so much scraping anymore as there was before? All right, so that is nice and dissolved. You can see that it's all mixed up together. Voila. All right. Now, we are going to get the dirtiest pennies that we found. These are the dirtiest pennies that I could find, just to show you real quick again. They're pretty dull, pretty dark, probably even oxidized. And we're going to place them into our bowl. Whoa, 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 whoa. Now we can actually see right down at the bottom of them that within a matter of moments, the pennies have actually started to clean themselves. We're not doing anything. We're not shaking around, not agitating it. You can see that the pennies actually just started to get cleaner. What's super neat about the pennies is that it may appear that they're cleaning themselves, but actually they're not. The copper oxides that had formed on the penny coating over time is actually dissolving in our mixture, in our salt and lemon juice mixture, or if at home, if you're using vinegar, your salt and vinegar mixture. So specifically, the lemon juice contains citric acid, and this is what is dissolving the copper oxide. If you're using vinegar at home, there's acetic acid that's in the vinegar, and that's dissolving the copper oxide. If you're a bit curious, like, what does this chemical reaction look like? Well, here we go. Here's the chemical reaction that we're seeing as our lemon juice cleans off the pennies. So the longer we leave the coins in the mixture, the cleaner they will become. And as we can see over here, they are getting cleaner and cleaner by the moment. See, look at that. Cleaner and cleaner by the moment. Okay, so basically what we're doing here is we're reversing the oxidation that had previously occurred on the pennies. The oxidation that had occurred was the copper oxides. We're reversing that reaction. So when we take the coins out of solution and put them in water, this chemical reaction, which is the reversal of the oxidation as the copper oxides are removed from the coating of the penny, this chemical reaction stops. So I'm just going to take my bowl of water right over here and just pull them out. Oop, sorry. Ah. I just want to show you how clean they are. Can you all see how clean they are? Just gonna grab a little napkin over here since I am dripping lemon juice everywhere by the minute. So you can see that they are super duper duper clean. And it did it all by the reversal of oxidation. How cool is that? Now when we put it in the water, that chemical reaction that was occurring is actually going to stop. Okay. So the longer we had left the coins in the mixture, the cleaner they would have become. And as we saw at first, they were getting clean, clean, clean. And over time, they got really clean. For 2 more minutes, they got really clean. Oh, look at this. Isn't that awesome, man? Look how super clean they are. They pretty much look like this. Super clean penny. One with no oxidation. The one I got earlier today. Super awesome. Okay. So what's pretty neat is if you decide not to rinse the coins off in the water, and instead you want to leave the mixture on the coins after you're taking them out and let them air dry, say on a paper towel, what you have actually seen is that over time, the coins would have started to turn a bluish greenish color. Now, for the sake of time, since air drying can take a bit of a while, you would actually see that this bluish greener color is developing on top of the coins. As you can see over here, it's a blue-green whitish color. Now this is because the acid-salt mixture, in our case, it was our lemon juice and salt, or you might be using at home, vinegar and salt mixture, is dissolving the copper layer that's on top of the penny. So with the copper layer gone, it's now easier for the salt's chlorine atoms, since salt is made of sodium and chlorine, NaCl, and the oxygen from our surrounding air that we breathe. As we know, our air is made up of nitrogen, oxygen, and a variety of other elements. So that surrounding air is enabling the copper atoms on the surface to join faster together. So this actually accelerates the oxidation process that would otherwise occur normally over time. So what you're seeing right here is called malachite. So malachite is a carbonate hydroxide mineral that we can see on our coins as a blue-green, a little bit whitish residue left over. Now, how I had said before, this is essentially speeding up the oxidation that would normally occur. So over time, these coins are just oxidation is going to occur and they're going to get dull and not pretty over time, completely acceptable and normal. Exposure to air, oils, and a variety of other different things going on in our atmosphere. But leaving them in the solution and causing them to air dry would actually result in the malachite forming because it would be speeding up the oxidation. And here's the reaction that had occurred earlier when we had seen our copper oxides combined with the citric acid yielding this, in which it was dissolving the copper oxides and stopping in water. All right. Well, thanks so much. Any questions? Leave them below in the comments. Thanks so much. See you next week.